Now as you can see, this horizontal scanning we are doing for a signal of 200.7 megahertz whose amplitude is minus 97 dBm with the help of this 40 dB attenuator here and 40 dB attenuator there. Now if we change the marker, you see the marker is being displayed here and it is reading 200.8, and if we move the marker from here to here, that is if we cover 10 divisions, it is like here it is displaying 200.1. So it is roughly around 800 kilohertz that it has swept. So the horizontal scan per division is around 80 kilohertz. So it is much lower if we further reduce the sweep width. It can go up till say 50 kilohertz for that matter. And if we decrease the sweep width by turning the pot clockwise, mind it, the video filter is switched on for better display, and if we change the marker, say like right now it is reading 550 megahertz and now it is reading say 5 megahertz, so it is covering say 7 divisions of 550 megahertz. So 550 divided by 7 is less than around is somewhere around 70 to 80 megahertz. So 70 to 80 megahertz is the scan width, horizontal scan width maximum for this spectrum analyzer. Now once again we decrease, we switch off the marker and switch off the video filter, so now it is in calibrated mode, and we decrease the sweep width. Now you can see we are almost able to see a signal here. Now this is a signal, and if you put a video filter you are able to view that signal perfectly. Now once again we are showing that if we increase the amplitude by 10 dB by here, the signal has been increased by 10 dB, further 10 dB, like that. So right now you are seeing a signal of minus 57 dBm. This is a variable control pot. You can see the 10 dB it is increasing. It's a variable control, and the signal right now is minus 57 dBm with a 40 dB already put into it. So if we keep on decreasing it 10 dB, it is now minus 67, minus 77, minus 87 and minus 97. So that means you are able to see or identify a signal as low as minus 97 dBm. So in order to measure the sensitivity of spectrum analyzer, you have to have a signal as low as possible, say like minus 100 dBm for that matter. So now you are able to see a minus 97 dBm of signal. For that the cable should be very good, it should have no loss. This is a double braided cable. The attenuator should not be leaky, and it should be able to identify a signal so that nothing is being leaked or being detected at this particular frequency. So this is the way to measure the sensitivity. Now there is one more point, that while we are setting up the display unit, the coupling should be DC for channel 1 as well as for channel 2. So this is something which we need to remember while setting up. In a analog CRT you can connect the channel 1 switch to DC coupling, and it should never be on AC coupling on both the channels. So once again, by increasing the sweep width, mind is a little this thing that when the pot is going clockwise, the sweep width is increasing. It is now in hundreds of megahertz, whereas if we decrease, it goes in few kilohertz. So right now it is maximum, and if we want to see any signal, that signal once again has to be brought to the center of the display, and then the sweep width has to be decreased. This is a point where the sweep width is entirely 0. So now you are seeing the signal in 0 sweep mode. And if you decrease, so if there is any demodulation in this signal source, you can see the demodulation also. So now you can see this is signal being demodulated because it's a FM swept source. So this is how a signal can be measured.